lobes of the brain, right? We even told the story of Gage, didn't we? The railroad worker, the one that had a lot on his mind. Then just checking if we're still on the same page. Well, today we're just gonna simply kind of draw out the ability of an impulse to be regenerated down the length of an axon, what it takes for that to happen, some terminology that goes with it, and then we're gonna jump into the senses and try to at least knock most of those out today. So. I'm sure the neurons in your body looks just like this, because my artistic ability is extremely precise. Are you laughing at me? Of course not. We have some cells in the nervous system called glial cells, and there's some in the peripheral nervous system, and there's some in the central nervous system. Some of them do the same thing, but put different names on them. These little bumps here along the axon, this being the axon, are called myelin sheaths. And myelin is made from a cell, a glial cell called Schwann cells. Now, Schwann cells produce myelin. Myelin speeds conduction. That's in the peripheral nervous system. In the central nervous system, there's another cell that does the same thing, but they name it different. It's called oligodendrocyte. Yeah, I don't know where they come up with that. I think they was drinking and had a speech impediment going on that night. But anyway, they just like to change terminology from time to time and mess us up a little bit. But definitely we want to know that myelin's purpose is to speed conduction. Okay, let me give you an example. We have basically 4 styles of neurons. We have large neurons that have a myelin sheath. We have large neurons without a myelin sheath. We have small neurons or thin neurons with a myelin sheath, and we have thin that don't have a myelin sheath. We go from your thinnest, which is your slowest, to your thickest myelinated is your fastest. Now, why would we, or where would we, need a slow acting neuron? Where in your system responds slowly besides your brain today? Jeez. Little help over here? I was looking in the wrong part of the room. All the smarties are over here, right? So we've got an answer? Digestive system. Thank you very much. Probably the last person I expected to speak over here. I didn't know he could speak, actually. The digestive system reacts, you told him that, didn't you, Katie? I knew it. The digestive system must act slowly to allow food time to digest. I mean, if food digested as fast as, well, the slow neurons, 1 meter per second. Our fastest neuron, 225 miles per hour. That's how fast it can. So if food's moving through your digestive tract at 225 miles per hour, not only will you be slapping the person next to you like, what'd you do with my food, but you'd be doing it sitting on the toilet. And that's just it's not a good picture to be painted at this point. So there is a reason why we have the things we have. So slow to fast, and of course skeletal muscle would be fast, wouldn't it? Now we did I'm pretty sure we did a reflex arc the other day, didn't we? Where a stimulus caused it, and a sensory neuron or a receptor picked it up. We didn't do that the other day? Well, a stimulus causes a reflex arc, and a receptor, which receptors could be taste buds, or it could be your eyes or ears or anything like that, picks it up. Sensory neuron takes it from the receptor, sends it to the central nervous system, to the association neuron. I'm talking faster. Association neurons, which eventually will come back by way of motor neurons to the effector. And the effector is what responds. That's either going to be a muscle or a gland that's responding to this. So if we reach out and grab something hot and not realizing that it was hot, and we grab it, what's gonna happen immediately? Drop that sucker immediately. Now, if we think it's hot, and we test it and say, oh, it's not that hot. Now, there's a pothole right over there, but we're too lazy to walk over there and get it. We're gonna make it, right? So we grab it, we get it part way to the sink and say, whoo, whoo, this is a little hotter than I thought it was. But we hang on to it long enough not to make the mess, and we toss it in the sink, right? So there is a mind over matter to an extent, but reflexes happen just like that. I mean, just immediately. So that's a reflex arc. Now, we're gonna look at threshold. Threshold is minimum stimulus to trigger a response. Would that be different? It should be different to everybody. In actuality, somebody in the medical field, they was looking at this lecture the other day, and they said they don't look at it like that. They think everybody's threshold is the same, but it's your ability to tolerate. It's your tolerance. It's what's different. I don't see much difference in either one of those perspectives, so you can look at it either way. So threshold, whatever level that is, triggers this response. And it starts right here at the axon hillock. And then this response is regenerated at each gap. These gaps are called nodes of reindeer. That's right. Somebody gonna think that's important. No. So the nodes of reindeer literally regenerate this current from where it starts to where it ends. And it does not, whatever level of threshold level it starts is the same level which it ends. In other words, it never loses amplitude. So they'll tell you in the books that you really shouldn't use the term conduct, because we don't conduct, we regenerate. And then it turns around in the book and says we conduct without decrement. Conduct without loss of amplitude. Whatever level it starts, that's the level it ends. Boy, if it's way up here, you feel the pain in the end, kind of deal. So, node of reindeer, if we look at a node of reindeer enlarged here, we have potassium inside, sodium outside, and I might ask you, what's the most abundant extracellular fluid ion? And that's sodium. If I ask you most abundant intracellular fluid ion, that's potassium. But what we have here is a negative 70 millivolts. This is like a little battery sitting there. It's really no different than a battery in a flashlight. When you flip the switch, we convert electrical to light energy, don't we? So here, when the threshold stimulus makes contact with it, it's probably using some energy to get there, but we regenerate that energy back in it to get it to the next one, that regenerates it to the next one. And as soon as it passes this one, it's called an action potential. Sodium rushes in, of course potassium's positive too, potassium rushes out, and this actually goes to positive 20, which means the electrical current that was in this battery was used to regenerate it to go to the next one. That's what that's saying. As soon as it does conduct it to the next one, I'm going to use the term anyway, the active transport pumps potassium back in, sodium back out. It's 3 sodium, 2 potassium, and we end up back to negative 70. We've recharged it. It's like plugging your flashlight back into the wall again to electric current and charging it back up. Now we're sitting there at negative 70 millivolts, ready to go again. Now it gets a little it gets a little more technical than this. If you look at different things, there's what's called an absolute refractory period and a relative refractory period. And those are basically answering the question, will it conduct another impulse while it's conducting an impulse? And it depends on how you look at it. If it's in the middle of conducting the impulse down the length of this axon, then the absolute refractory period comes into play and says, no, absolutely not. We're already conducting one. I don't care what subsequent impulse comes in after that. Until we get finished with this one, we cannot conduct another one. Then the relative refractory period says, if we're darn near finished with this one, and I'm sure it says darn near in the book, if we're darn near finished with this one, then, and if the second one is a stronger stimulus than the first, we'll consider conducting that. And so what it's saying is these are regenerating, they're nearly back to zero. They may not be negative, but they're not positive. We're recharging them. We've got some impulse there. If this stimulus was up here, then we'd probably conduct the second stimulus. But, I mean, it's the difference between somebody pinching you and somebody hitting you with your hammer. There's your different stimulus. You certainly feel the difference. All right, so we conduct down the length of the axon. We jump from node to node to get there, and that's called saltatory conduction. The book says don't use the term conduction, but they did several times, so we will too. Saltatory conduction means jumping from node to node. So this is all electrical, 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 electrical. And then we reach the synaptic cleft. The synaptic cleft has to be bridged by a chemical called neurotransmitter. Neurotransmitter most commonly used is acetylcholine, ACH. Acetylcholine is given off by the synaptic end bulbs, and it bridges the gap, and it does it from the initial stimulus. The initial stimulus causes calcium to be released. Calcium rushes ahead of the stimulus and tells them to bridge the gap. So when we go electrical, 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 chemical, electrical, 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 we never miss a beat. We built a bridge, recharged itself off the chemical excitement of the bridge, continues to move down the next axon. As soon as it passes the chemicals, there's an enzyme called ACH-ACE that destroys acetylcholine. These, each one, have regenerated themselves, and this neuron is ready to actually conduct an impulse again. Amber, you remember any of this from chapter 7?
I don't know what chapter, but
It was
I know
chapter
it's
7.
physiology.
Yeah. And we're putting it all in a nutshell. It took us about a week to cover that one chapter, but you're gonna get it all in one day here, so. Let's see, we're to use the term conduct without decrement. We don't lose amplitude. Whatever level of threshold starts here, that's a level of threshold we end down there. So by the time it gets to the brain to be interpreted, your brain's not saying, what was that? We know exactly what it was. There's enough information to interpret that. Does anybody have a question at this point?
So, okay, like as you're sitting here talking and I'm talking to you and your brain is like hearing the words and telling you what I'm saying, is there any like lag, like time, you know what I mean? That we don't know, obviously, but you know what I'm saying? Like how long is
There's
that?
some lag here.
Is that taking like time or is it just like as, you know, cause.
Taking time from you to me in our
Yeah.
consciousness, no.
Like, cause, okay, you know in like astronomy, they say the star that you're looking at is actually like millions and millions of years
Light
ago.
years away.
Yeah, like that was such a long time ago, like, but we don't really notice that when we look at it.
As we see it.
Yeah, but when I talk to you, like, is there any time from when it takes your brain to say, oh, she just said whatever? You know what I mean?
Keep talking, I'll tell you. Got my clock out now.
I mean, I know that you can't tell, but there's just, your brain just knows.
Well, you know what Sir Charles Sherrington said? He said that we'll never understand the brain because we're trying to understand the brain with a brain which we don't understand. So, I don't understand what stem hill you're asking me. I kinda know what you're asking me, but I don't think we can answer it. Maybe we can answer it. Maybe it's just no. Maybe I need to flip a coin for that answer. If I had a coin, I'm a teacher, I don't carry much money.
What did you say that the sodium was most abundant in?
Extracellular fluid ion, ECF ion, extracellular fluid.
And then the potassium was the?
Intracellular fluid, yeah. That's probably on the study guide somewhere. Okay, no questions over this? Now, let's, one thing I probably missed the other day, is I think we kind of finished off with the different lobes of the cerebrum, right? And we told the story of Gage. I think that's kind of where we ended. What does the occipital lobe of the cerebrum do? What's its specialty? Occipital, vision, temporal, hearing, frontal. Keep going. Language, memory, some speech there. What about the parietal? touch, pressure, pain, yeah, parietal. Would you agree that some of those, or maybe all of them, communicate to each other one way or another? That there's gotta be some association areas between parietal and temporal, or temporal and occipital, or, would you agree? So if I asked a question like this, and I said, this might even been on physiology test, I don't remember. If you looked out that window and you saw sitting in a tree an African bluebunt bird, and the African bluebunt bird commenced to singing a very high-pitched song that was so high-pitched, it was so shrill, that it was painful to listen to. Even so painful, it's a noise you'll never forget. Now, what lobe of the brain did that affect?
Oh.
Forget, that's frontal, right? Memory. You heard it, temporal. You saw it, occipital. It was painful. So you had parietal. So the next time you hear this noise from a distance, what's the first thing you think? African bluebunt bird. Where's my gun? I mean, that's what we think around here. Let's shoot it. When in doubt, just shoot it, and then we'll figure the rest of it out later, right? So if you see the bird sitting over in a bush, holy smokes, I hope he don't start singing. See the association? Whether you see it or whether you hear it, I mean, it's associating to the other things that went along with it. As soon as that shrill noise starts and pain commences in your brain, you know exactly what it is, because you have recall areas. They tell you in this book as well that we have a slight advantage over a lot of animals in that we have what's called a neocortex. What does neo mean? Come on, mamas. It's new brain. Are you even functioning today, Leatherwood?
No.
It's like talking to a rag doll over here. We have a new brain, which gives our brain a little more size, a little more capacity, compared to the paleocortex that most all animals have, which only typically deals with instinctive behaviors. That's those little unconscious things that we have to do to continue the species, continue the process of living. So, what does the neocortex, what advantage does it give us? What? Some thought processing, for sure. We can reason out something, logical thinking. We can actually sit here and learn by hearing. How many times you holler at your dog and tell him to stop doing what he's doing, he gets run over anyway. Stop chasing that car, smack. Stupid dog, you know? Yeah. How many times I've got this one persimmon tree. I don't know, I think possums come from all over the world to eat off this persimmon tree. Invariably this time of year, there'll be families of possums in the road dead because it's right beside the road. So go by there one day, there's a possum. Well, you know, Cousin Joe said, well, look at Sally got run over. Let's go see if she's all right. Smack. Cousin Joe gets run over. So you get a whole family. You know, we can see a possum dead in the road and think, stupid possum. You really shouldn't play in the road. Wife called me the other day, said, what's the kids doing? She hadn't made it home from work. I said, oh, they're down playing in the road. She said, please don't tell me that. I said, I don't know, I heard them a while ago. I'm busy right now. She hates to leave them with me that way. She's afraid I'm gonna kill them all. First two survived. My mother-in-law used to call and she said, what's Nick and Sabrina doing? I said, they was heading toward the pond. I think they said they was gonna go swimming. They was just 5 or 6 years old. She's like silence on the other end, like, you sorry son-in-law. Anyway, I get them to watch them a lot because they think I'm terrible. So I get my free time. Well, let me tell you a little story, and you tell me really what's going on here. This is really a comparison of the capabilities of an animal learning to the capabilities of us, okay? Would you agree we would have or should have a higher capability of learning above and beyond the average dog, for instance? Wouldn't you think? Yes? Okay. Does anybody disagree with that? Okay, I'll make sure. You never know. I'm going to tell you a story of a dog named Ben. Ben was a dog it was my dog I guess he was mine. Nobody else in the family liked the dog. I don't even remember how old I was, probably in middle school to lower high school, something like that, maybe. But he was a Heinz 57 dog. He didn't stand up very tall. He didn't have a tail. That's what we named him Ben, after Ben the bear that used to be on a lot of shows back in the day. And he looked like just a little bear when we got him. And there was a lot of things on the farm he liked to do. He liked to chase coyotes, I guess, because he absolutely hated them. And coyotes scared to death of him, although they were bigger than him. He'd see a coyote and take off, just running fast as he could run. And I've watched this many times and think, there's no way. And this coyote's like, this little mutt coming at me. And never slow down. He's thinking the mutt's gonna come up there and bow up to him. He never slows down. Bam, he hits him full throttle. And they go to rolling. And the coyote gets up and takes off, and Ben hits him again from behind as far as you can watch. Ben, bam. It's like, well, one of these days he's really gonna piss off a coyote and there won't be any more Ben. The coyotes just quit coming around. He was just a nuisance to them. But that was a pretty neat thing he did. He played fetch. He was pretty smart playing fetch. His biggest downfall, I guess we all have weaknesses. He loved to chase vehicles. And after we run over him twice, his own owners run over him twice. That's how stupid he was. He did learn from it, and I'll tell you how he learned. We run over him the last time we hit him was just turning in the driveway. He was so excited about us coming home. We turn in the driveway and he just runs in front of us. So we're not going very fast, so we just clip him, and he's laying over there in the yard. Say, you all right, Ben? Stupid dog, get out in front of the car. Well, then he started, instead of chasing vehicles, I think he started racing vehicles. Because now, he had a pattern. Vehicles coming from the east, where our house is sitting, he'd come off the carport, he had a trail through the yard, and he'd cut, not get in the ditch or in the road, he'd cut and go under the fence, and he'd stay on the fence side of the pasture and just see how far he could race this car. And I raced him one time. I was coming so he started doing it to me, and I said, how you doing, Ben? I just kept speeding up. About 27, he topped out at 27 miles an hour. Now, he couldn't sustain that very long, but he always followed the tractor around, regardless of what you had on it. Whatever equipment, brush hog, sickle bar mowing machine, yeah, we like to cut his foot off of that. You couldn't make him stay home. You couldn't get him out of the way. So we almost cut his foot off, so we bandaged that up. He got over that, and he liked to jump in the back of the truck and go with us everywhere in the truck. So Ben, get in the truck. And being the smart aleck I was back then, boy, he'd come around and jump in the truck, and I shut the end gate real fast, and he'd smack. Well, yeah, I'm sure he got some brain damage from that. But he learned from that. See, I was teaching him. I knew then I was going to be a fine teacher. He'd get ready to jump in the truck, and he'd stop me and look at me like, what are you going to do? You going to help me up in there? You going to close the end gate or what? And then if I backed up, he'd jump in. If I stood there close, he'd just look at me like, no, I don't think so. So I think he learned from that. But we'd get him up in there. We had a neighbor that had that Heinz 57 bunch of dogs that they never fed. You all have neighbors like this, right? And when they laid around, they laid halfway out in the road, and they just in the way all the time. Ben hated that bunch of dogs. So we're coming down the road to my grandmother's house, and he's leaning up by the cab. He's leaning over the side. And he's just giving them what for. Of course, they're lining up on the side of the road. And I mean, it's just a big cuss match. And Ben's all the way down the side of the truck, right, hanging off the back of the end gate, giving them what for. You just want to just line them all up and just shoot them all. Well, Ben got a little aggressive on that last and fell out of the back of the truck and broke his leg. Yeah, he was laying there. The rest of them thought he did have a mean bark. I mean, it sounded like he was going to rip your head off. And so I guess he kind of had his bluff in those. As long as he's in the truck, they's real brave, you know. When he come bailing out of that truck and unintentionally broke his leg, they scattered like he's really after them. Well, I couldn't believe Dad actually fixed his leg, but he did. He spent $100 and pinned his leg back together. And now Ben had almost one foot cut off, and now he broke the other hip. He's not walking so good. He's not doing no 27 mile an hour, I promise you. Well, as we went on through life, can you see where he's learned through this process? He never leaned over the back of the end gate anymore, I'll tell you that. Later in life, Darren's familiar with this, down west of my dad's house, there's a 90-degree curve. There's a lot of people, when they're not seeing the road straight at night, they straighten our curve out and end up in our pasture. So many people from Arkansas that come over here to get bigger come the back roads, and they straighten that road out. Well, this particular time, I think they went through the fence, decided they didn't want to get caught drunk, so they drove back through the fence to get back on the road. They missed the road, went through the neighbor's fence. They went through that fence, come back on the road, missed it again, but they got turned and clipped our fence again before they hit the road and drove off. So we was busy. We was fixing a lot of fence. Still to this day, I don't know who that was. But, so we're down there fixing fence, and Ben's down there with us. He's sitting in the road ditch there. Here comes a truck. Well, he's bored. Oh, here comes a truck. I can see him crouching down, getting in position to leap into action as the truck comes up. But being the smart Ben he is, when the truck's front wheels got even with him, he resisted because he knows there's back wheels, right? We've hit him twice already. Back wheels get even with him. He burst into action. Man, he chased those back wheels. He just didn't see the stock trailer on the back. Stock trailer got him right in the back of the head, rolled him under both axles, and he come out the back pretty beat up. He was bleeding about every orifice, eyeballs was dilated. I just go out there and drag him out of the road, and of course you could have stood there and yelled at him his whole time, bam, bam. Didn't good. So you just let him get run over. So I threw him in the ditch. We was almost finished. We got finished what we're done, and I'm fixing to go throw him on the trailer to drag him off to our dog graveyard we've got in back pasture. And he is setting up in the ditch over there. He's a little wobbly. He's bleeding out his mouth. His pupils were dilated. He's like, I don't think he could have heard a word you said to him. I picked him up, put him on the trailer. He actually lived through it. I figured he'd have sustaining injuries, internal or something. He lived through it. What he sustained from it was severe brain damage. Because at this point, if we played fetch, he'd go get it, bring it to me, and he always fought with it before he turned loose and we'd go again. Now we'd fight with it, he'd get mad, he forgot what we was doing. And at one time I finally pulled it out of his mouth to throw it again, and he latched on my arm. He didn't bite down. It's almost like, I can't believe I just bit the hand that feeds me, you know. And I thought, this dog's nuts. And he likes sitting on the porch. So every time Mom come out to sweep the porch off, she'd slap him with a broom. He'd get out of the way and she'd sweep the porch off. Well, this time she slapped him with a broom, and there wasn't a broom left. He just gnawed it all to pieces right there. Well, you don't do that to Mom. Mom put out a hit on him. That's enough of Ben. Ben almost ate up one of her neighbors. He's known, he come to see us for something, and Ben almost ate his leg off. So Ben's really becoming a liability, if you will. My brother was going to school at OSU at the time, absolutely hated the dog. Dad and I was kind of attached to the dumb dog for some reason, and Mom didn't have the heart to shoot anything. So she put a hit out on him, so we made the call to the hitman at OSU. And he never come in for anything. But needless to say, Dad called him. I was on a Thursday, I remember it specifically. Said, what are you doing this weekend? Oh, I think he kept a list by the phone. Oh, I've got this to do, and this to do, and this to do. That's to keep him coming in. And he said, well, Ben kind of attacked your mother the other day, and he's probably a liability to the family. We really don't need him around anymore. He was in that night. He just, forget Friday classes, he just come right on in. And Ben died of lead poisoning. But would you agree that Ben did learn throughout his life? Now, if we'd have set him down in a chair, wouldn't it be nice sitting right there in a chair beside you? No?
You're not biting me.
Oh, no. Surely not. Well, after he had brain damage, you probably would have. And a lecture to him, he was not going to learn from that, though, was he? We told him to quit chasing cars, but he learned to chase cars in a way he didn't get run over, but he hadn't learned the perspective of a stock trailer yet. So slow, gradual learning by doing. Would you agree? Is that not the better way we learn, is learn by doing? How many times your mama tell you, don't do that? As soon as she turned her back, you did it anyway. Don't touch that stove, it's hot. Oh, it's hot, is it? So you've done it, hadn't you?
I used to do it like at this Mexican restaurant, they'd always tell me my plate was hot and I would just touch it anyway.
Yeah, I think she's kin to Ben. If we compared Ben's brain to hers, we'd have a close comparison, wouldn't we? But that's, I think it's a good comparison. Can animals learn? Yes. Some animals are highly intelligent, aren't they? I mean, they pick up on things pretty quick, usually by doing or by practice. That's typically how you teach a dog. I mean, if you put a dog collar on a dog and shock him enough for whatever he's doing, he'll stop it eventually, won't he? You never done that before? That's how they train a lot of bird dogs. And oh, you've done that. Yeah, I can. She's evil.
She just tied the electric fence to it.
Yeah. Anyway, there's a story of Ben, and I think it has application in today's society, and it compares the neocortex to the paleocortex and the ability we have. Now, whether we use it or not, you'd be like Raina and do it anyway. Whether we use it or not, that's our own choice. You know, whether we, yeah, my parents told me I really shouldn't drink and drive, but I did it anyway. That's my third car I've wrecked. You're a slow learner if you do that. So, rest of this chapter, I think, dives off into the senses. What part of the brain would you guess to be long-term memory? You remember, Amber? From long-term memory is laid down here. Apparently yours is not working.
Yeah.
It would be the hippocampus, and that's listed on 739, the hippocampus. All right, now here's some specialties. We talked about the different lobes. Let's look at the hemispheres. This is on 740, if you will. Higher mental activities, conscious mind is what they're referring to here. This is you thinking. That's the problem with people today is we tend not to think before we do. And that's a process of training. And I don't know, if I had a nickel every time I told my kids to think before you do, I'd be a wealthy man. But instead I'm even more broke than ever before because they didn't listen. The conscious brain deals with higher mental activities, planning, reasoning, memory, integration, and sensory information. Memory appears to transcend all parts of the brain rather than being a property of any particular part of the brain that was once believed. In other words, I think we associated that a while ago with the pain of the bird singing and the actual seeing the bird or hearing the bird or feeling the pain. The two hemispheres, if you're right-handed, you're probably left hemisphere dominant. If you're left-handed, you're probably right hemisphere dominant, or at least that's 70% of the cases on left-handers. There are 30% of left-handers that are still left hemisphere dominant. Confused now? So left hemisphere seems to be for language development. How many right-handers do we have in here? Because I'm fixing to burst your bubble. We got any lefties at all? Okay. This explains a lot for both of y'all. If you're left hemisphere, you're right-handed, you're mathematically inclined.
If you're right-handed, you're mathematically inclined?
Yeah, you're a mathematical
I'm pretty
wizard.
good at math and I'm right-handed.
You're good at math and you're right-handed.
Yes.
That is exactly what it's saying.
Wait, what?
You're left hemisphere dominant, which
Okay.
means you're right-handed.
Yeah.
You're good mathematically.
Oh, well, the way I asked it, you said yes, but I said obviously.
Yes.
Okay.
Left hemisphere is for language, mathematical, and learning capabilities. And some sequential thought processes. You can actually put together 2 or 3 thoughts at the same time without losing it. Okay? The right hemisphere is for spatial, musical, artistic, intuitive, and perceptual activities. That doesn't fit you at all. None of them. We gotta have something out in left field for you to fit in. So of course, the opposite hemisphere controls the opposite side of the body. Damage to the left hemisphere usually causes loss of speech and may have disastrous effects on intellect, left hemisphere damage. Because these differences in brain symmetry and function exist at birth, they appear to be inborn rather than result of development or environmental effects as once believed. Inborn in that it's genetic background from your parents. Somehow, it may be grandparents that shifted over to you through the genetics of the parents, but somehow it's affected you. All right, we made it through that. We've already talked about that. Now we're ready to go to the sense organs. Here we have the sense organs on 742 and 743. First, we're going to talk about chemical senses. Now, interior receptors, exterior receptors, whether it be chemical, mechanical, light, thermal, these are all in a category of senses prior to getting into hearing and seeing. So if it's a chemical receptor, taste buds would fit that, wouldn't it? Anything else hit chemical? Smell would smell, it hit chemical, wouldn't it? What about touch of, what about hot and cold, sense of feeling? That would be a thermal, skin probably involved with that. Mechanical could be skin, touch, or pressure, but it could also be in the ears for mechanical sound making. So you got a couple different ones there. And they list all those. And then they get to taste and smell. Well, taste and smell, would you agree they go hand in hand? I mean, if you have a cold, does food taste as well? It usually doesn't, does it? Smokers. They don't taste. Any smokers in here? Do you Buffalo Sisters quit smoking? They don't smoke cigarettes. They go for the good stuff. You smoke them? It's bad for you. Okay, as long as you know that. I've done my job. If, in theory, which is always in theory, you wouldn't taste food like somebody that didn't smoke, because the smoke tends to hinder chemical receptors. Now, some smokers will smoke as a form of diet because they won't eat as much if they're smoking. You've heard of that. As soon as you quit smoking, everything starts tasting good again. So I think a lot of smoking habit is just you gotta move the hands, gotta have something in the hands. So food in the hands replaces the cigarette in the hands, and we gain weight. You like cigarettes and food. Well, I'm not gonna tell you to smoke more because that's even worse. Go with a straight Camel, no filtered. Maybe that'll just cause cancer faster. Don't do that. So, taste and smell going hand in hand. You know, we can distinguish over 10,000 different odors. Now, how do you go about describing 10,000 different smells? Where do you start? Name one. Name a smell. No, that's an animal. You started number one as smells like. Sweet. I can live with that.
Smells and tastes sweet.
Do I?
Things taste sweet too.
We're talking about smells, so we can apply it to that. At least it wasn't an animal. Tastes like a skunk. Y'all would know that only the Buffalo Sisters would eat skunk.
It's a skunky.
If you get a good whiff of a skunk, it seems like you're tasting it, doesn't it?
Yes.
Run over one and get you a good whiff of that. Have you ever clipped one and get the smell and roll down the window and crank the air conditioner on, try to blow it all out, and then you get to where you're going, you think everything's okay, and somebody said, "Whew, you stink." Of course, you probably get that anyway, don't you? Taste and smell do go hand in hand without a doubt. When we start describing, obviously we can't describe taste very well. When we describe smells, we didn't do a very good job with that either, because we think it's a skunk. Everything's a skunk. But if you start describing a food to somebody, what's the strangest food you've ever eaten? I know you've eaten some weird things because I know where you've been eating. And they probably didn't tell you the whole truth about what you've been eating. Nobody eats anything strange in here?
Trout cheek.
What?
Trout cheek. Cheek, muscle, trout.
Trout cheek. I didn't even know they had a muscle in the cheek. I learned something today. Can you imagine cleaning a trout and I'm going after the muscle in the cheek? And it's do all that work for one little bite. Does it taste different than the real trout itself?
Saltier.
Saltier, so it's really, you're pulling a gland out. Okay.
I've had them smoked a heart one time. I think
You
it was a
smoked
deer.
heart?
Yeah, I think it was a deer.
A deer smoked heart.
Yeah, my dad ate a fried heart like last week. I was just telling her that. He said it was really good, but I was like, no. thanks.
You didn't jump on that?
No.
Fried heart, smoked heart. Anybody had any gator?
Yes,
Yeah.
You like that?
yes.
You really like that? I ate some gator one time, tastes like a rubber chicken. It was horrible.
It's
You
like
gotta have
spicy
something on it.
chicken.
Well, depends on how you cook it, I guess, but I had some gator that I thought was pretty good. It was cut up little chunks made in a gumbo, and I thought that was pretty good. But this other piece floating around and whatever that was, wasn't very good. It was pretty rubbery. What's some other weird stuff?
I had ate a sardine before when I was little.
You know, that's really not considered weird.
I mean,
because
cause my dad ate them, like put lemon on them, but I would never, ever.
cheese,
It
crackers,
was
and
just cause I was
sardines.
little, I would never ever do it.
It's a
again.
quick diet, because you eat them and you won't wanna eat for a while, and you
Yeah.
probably throw up later.
Yeah.
Well, I guess I'm gonna have to quickly get to my point, because y'all aren't helping me a whole lot here. My point is, if you were eating something, and you've had it before, and you really like it, and you wanna describe it to your friend, oh, you gotta try some of this, you gotta go to this and such restaurant, you gotta try this plate. And they'll say, well, what is it? And you tell them what it is, maybe it's calf fries. What's it taste like? That's your next question. What does it taste like? How do you describe something to them that they've never had before?
There's something that they have to have.
Tastes like
That
chicken.
you know.
Everything tastes like chicken. And it doesn't, but that's gonna be the descriptive concept is, well, it's kinda like chicken, but it's not. You know what I'm saying? Well, you've had, Kentucky Fried Chicken, well, it's not that. You've had, smoked chicken, that's not that. But it's kinda like chicken. What does frog legs taste like? Anybody had frog legs? What does it taste like? Fishy chicken. Just a fishy hint to that chicken leg. I love them when they're jumping around in the skillet and they're not even attached to the frog. Those nerves, they get some hot grease and boy, they start giving it all that in the skillet, and you take that spatula and you kill him again and keep him in the skillet. Yeah, but it's more fun swatting him, trying to jump out. All right, any questions there? All right, moving on over now to, it's been painful enough, let's pass the pain. Let's go to hearing. And, may not make it through eyesight today, but, we'll do hearing real fast. Okay, so basically the hearing process has two components to it. It has a component that deals with balance and coordination, which we call the vestibular apparatus. The vestibular apparatus has a semicircular canals in it, right here. Has three of those lying right angles to each other. And at the bottom, it has a utricle and a saccule. Down here at the very bottom, these bulbs down at the very bottom, utricle and saccule. Part of your middle ear deals with balance and coordination. Any which way you turn your head, there is a fluid in there called endolymph that will run up and into one of those semicircular canals, which will brush nerve endings, bend them, send a message to your brain, which will tell you you're leaning to the right, leaning to the left, to give you a balanced coordination process where you don't just stumble and fall for whatever reason. So that's your vestibular apparatus, and I think anybody have your study guide out? There is a balance organ in invertebrates called a statocyst. I don't know what question it is, but it asks for the balance organ in invertebrates, and it's called a statocyst. Maybe I just dreamed it up. Maybe it's not on there. Anyway, from that, we start looking at the actual hearing process. So if we funnel sound in, we obviously can hear things in front of us better than we can behind us, right? If we funnel it in, it comes in, flows through the external auditory canal. Would you agree that earwax could hinder hearing? Sure. But it also protects our hearing because it keeps dirt and debris and other things from getting in there. So we go to clean the earwax out every now and then. We stick a Q-tip in there, right? Which the doctor says, don't stick a Q-tip in there because you're impacting more wax down in there, which inhibits, but we do it anyway, don't we? Of course we do. Well, you want me to stick in there a pen? Yeah, I just stick me a pen in there and rake out a big chunk every now and then. So sound comes down through here and it hits the tympanic membrane right here. The purpose of that is to direct sound. It really doesn't do anything but send sound where it's supposed to go. It directs it over to the ossicles. Can you hear without an eardrum? Anybody ever had a burst eardrum or know somebody that's had a burst eardrum? You can hear without it. You've had one. No, but you know somebody. You may have some hearing loss, but you can still hear without it. And it directs sound to the ossicles. The ossicles are the malleus, incus, and stapes. Hammer, anvil, and stirrup in that order. And their purpose is to amplify sound. It amplifies it even more. So the stapes is connected to the oval window, which enters into the cochlea. The cochlea is where your sound receptors are found. Those sound receptors are called organs of Corti. And so as sound waves enter the cochlea, now we have more fluid. It's like dropping a rock into a pond and waves come out from it. When these vibrations hit the fluid, then we get waves going through the fluid. The waves bend the hair cells, which are called organs of Corti, and that sends a message by way of the vestibular branch of the vestibulocochlear nerve to the brain and interprets that sound. The more the hair cells are bent, the louder the sound. Less they're bent, quieter the sound. So it has a lot to do with it on volume, put it that way. There is a stapedius muscle. I don't think it's listed on this, but there's a muscle that is connected to the stapes. And this muscle's purpose is to prevent hearing loss. If there's a loud noise, say you're running a chainsaw, Darren, that's loud enough. Honestly, you should wear hearing aids against that. Or driving an open cab tractor, crank down, running pretty big, you should wear hearing protection against that. The stapedius muscle, what it does is pull the stapes away from the oval window and prevents ossicle amplification. So now, if it's coming in already high and we prevent amplification, it still may be so high that it causes some hearing damage. But it's not going to be because your ear is amplifying it more. Now, something real fast, like a gunshot, it cannot respond that fast, so it's not going to help. So, preventing that amplification. Now, that's another question. How many decibels does it take to start sustaining hearing loss? What's the decibel level? You're close. Drop down a little. 90. About 90 decibels sustains hearing loss. They found one time there's some children's toys that was over 100 decibels. That was the ones the uncles and aunts was buying, you know, for them to torture their nieces and nephews. But they make sure of that now. But what if 90 is sustaining hearing loss? How many decibels brings on the threshold of hearing? What level of decibels can you start hearing? How many does it take? That's a little high. Lower. Lower. 0. They based it off human hearing standards and they started it at 0. So we can hear, threshold of hearing for humans is 0 decibels. Doesn't really make sense to me, but that's what it is. Kinda like your question. All right, covered that. Status, this is on page 748 in case you was interested. All things left vision. We're gonna quit right there and, last, we'll come back here for lecture Thursday. I'll finish vision. We'll probably get started in the next chapter, but we'll go on the lab. Try to get out a little early. Get our, how many presentations we have left?